Hello and welcome to 5-Minute Math. Today we're looking at the second grade concept of geometry, specifically how we can use different words to define and to classify three-dimensional solids, and we'll do it in 5 minutes or less. So I'm starting with three solids here, the sphere, the cone, and the cylinder, that all have curved surfaces, because we're going to use different words to describe these three-dimensional shapes. So the first term we're going to use is a curved edge. And so our sphere doesn't have any curved edges, so we can say it has 0 curved edges. And we can see our curved edge on this cone, so I'm just going to call it a CE rather than rewriting the word curved edge. So I'm going to say it's got one curved edge. And that's where we have a circular base and a curved surface where they meet. Kind of like a regular edge on a rectangular prism or a cube, but as you can see, it's curved. So our cylinder, which is kind of like a Coke can or a soup can, it's got two curved edges, one at the top and one at the bottom. So if we go down to the second row, we see circular bases. Circular bases are flat surfaces that the shape can rest upon. So as you can tell, our cone has got one circular base. It's down at the very bottom. And our cylinder actually has two, so you can set it on its top or set it on its bottom without it rolling away. So we're going to say it has two circular bases. Now, vertices are kind of points when we're talking about these curved shapes. And as you can see, no vertices or a vertex is what you'd call one of them on a sphere. A cone has got one. It's got a point up at the top, and it's a different type of vertex than you would see on a three-dimensional solid like a cube or rectangular prism. So the cone's the only one that has one. Cylinder doesn't have any points. And then finally, curved surfaces. Finally, the sphere has something. The whole shape is a curved surface. I'll just shade in the whole thing green. The entire thing is one big curved surface. The cone has got one curved surface as well. It's this top part that kind of wraps around on itself. So that's got one curved surface. And then same thing with our cylinder. It's got this one curved surface that kind of wraps around. So those are the terms that we could use to describe a sphere, a cone, and a cylinder. Now let's look at what happens when we try to describe other three-dimensional solids. Three new three-dimensional solids: cube, rectangular prism, and triangular prism. So edges are where two faces meet. So on our cube, we've got 1, 2, 3, 4 edges on the top, 5, 6, 7, 8 edges on the bottom, and then we have 4 connecting edges between the top and the bottom: 9, 10, 11, 12. So our cube has 12 edges. And you know what? We could say the same thing for our rectangular prism. We've got 4 edges on the top, another 4 edges on the bottom: 5, 6, 7, 8. And then 9, 10, 11, 12. We have 4 edges connecting the top and bottom. So 12 edges on both the rectangular prism and the cube. Triangular prism is going to be a little bit different. So 3 edges on the triangle face, another 3 edges on the second triangle face. So that's 6, 7, 8, 9 connecting. So we have 3 on each face and then 3 connecting for a total of 9. Now faces are flat surfaces here. So on the cube, we've got 1 on the top, 1 on the bottom, and then 4 all around. 5, 6. All together, we've got 3, and then the side 4, and then the back 5, and then the side 6. Think of rolling a die. You've got one number on each face, so 6 faces. We're going to find the same thing on our rectangular prism. It also has 6 faces, 1 on the top, 1 on the bottom, 1 on each side, and then the front and the back. So that's going to be 6. We only have 5 faces on our triangular prism. To the 2 triangle ones, and then you got 1, 2, and then 3 rectangular ones. So that's a total of 5. Vertices are corners. So we've got 1, 2, 3, 4, 5, 6, 7, 8 corners on each rectangular prism and our cube. And then we have 1, 2, 3, 4, 5, 6 corners on our triangular prism.